So the whole idea of subsets and elements and things like that. So this is not the same thing as this, right? This is A, which might itself be a set. This is the set that contains A as an element. Okay, so A is a subset of A. A is not an element of A. A is an element of the set that contains A. A is not a subset of the set that contains A. All right. I think in Principia Mathematica, Bertrand Russell reduced, or I guess Russell and Whitehead, reduced all of mathematics to the empty set and sets containing the empty set. So this is a little bit of culture. So how do you build up the integers out of the empty set? So you have to have this notion of a one-to-one mapping. So you represent 0 by the empty set itself. That set has no elements. Okay? How do you represent 1? You need a set with 1 element. Well, what is that element going to be if all you have is the empty set? That element will be the empty set. Okay, so this is deemed to be sort of equivalent to 0. That set has 1 element, namely the empty set. Okay? How do you make the number 2? You need a set that has 2 elements. What could those 2 elements be? Well, one of them could be the empty set, and the other one could be the set that contains the empty set. So you build, so this is the number 1, and the number 2 is this set, which contains the empty set as one of its elements, and the set containing the empty set as its second element. So that is equivalent to the number 2 in this representation. Okay, so they build all of mathematics from the empty set and sets containing the empty set.